Hi, today I'm going to explain the comparing prediction performance for crash injury severity among various machine learning and static methods. So we are the team Bhuvana, Madhu, Prashant. So we are going to explain this project and I'm going to explain the abstract. So crash injury severity prediction is promising research targeting traffic safety. Traditionally, various static methods were used for modeling crash injury severities. In recent years, machine learning based methods are becoming popular due to their good predicting performance. So the aim is focused at comparing the predictive performance, including prediction accuracy among various machine learning methods with distinct modeling logic for crash severity analysis. The correct prediction rate for each crash severity levels and overall correct prediction rate were calculated. The main task is comparing and predicting accuracy of six methods, including KNN, decision tree, and random forest, SVM, OP, and MNL in the predicting each crash severity. And let's go to introduction. So crash injury severity modeling is of great interest to many traffic safety researchers. Crash severity models can predict the severity that may be expected to occur from the crash, which helps hospital provide proper medical care as fast as possible. In addition, studies on crash injury severity can also help better understanding what factors contribute to injury severity. Once a crash occurs, which helps reduce crash severity and improve road safety. Crash severities are usually measured by several distinct categories, which are fatal, incapacitable injuries, non-incapacitable injuries, possible injuries, and property damages only. Traditionally, the most common used methods for crash injury severity analysis are static models. So, static models have advantages that they output clearly formula between dependent and explanatory variables and the results are easy to interrupt. But static models have some advantages. For example, static modeling technique required assumption about the distinct of data and linear functions is used to link the dependent variable to explanatory variables. To overcome the limitations of static models, previous studies have applied machine learning methods for crash injury severity predictions. Machine learning models do not contain pre-assumed relationships between variables. Those machine learning methods have been reported to produce better fitting than static methods. A major limitation associated with the affirmative machine learning methods is that they generally work like a black box, which does not directly report the correlation between crash injury severity and explanatory variables. So the problem statement, the primary object of the study is to compare the predictive performance for crash injury severity analysis between six machine learning and the static methods based on crash severity data collected. So let's go to objective. So the idea explains the best algorithm for the detecting injury severity among various machine learning and static models. For injury severity, five levels are maintained to know the level of injury. For injury severity, first we train the system using various algorithms and find the level of injury severity. The algorithm includes machine learning and static models to compare the results accuracy. So the flowchart will be explained by my friend Bona. So
Hi, now I'm going to explain regarding the flowchart. So first we will identify the problem, that is the injury, and secondly we will collect the accident data. So after collecting the accident data, we'll evaluate based on various characteristics or factors. So then we will compare the analysis. So analysis and comparisons are conducted to show the change in accident rates, and comparative analysis and modeling of data analysis is carried out to predict accidents and fatalities. So prediction and accuracy comes at the end. Coming to the data sets we are taking from the past 3 years data, and here we are using two types of data sets. So here, first, initially we are taking data.csv. So this data.csv will be in this format, considering all the different factors here. And when we pre-process this data.csv, so we will give this data.csv for pre-processing. Then we will get the data set, that is so here we have taken two data sets. This is the first data set 1. Here we are having around 7,000 records, and in second data set we are having 3,000 records. So here, these are the factors we are considering, like light conditions, weather conditions, collision severity, and collision reference number, the date of collision, day of collisions, and so on. So these are the methods we are going to use. So there are 6 different methods. One is KNN. KNN is K nearest neighbor. So here the K nearest observations were considered, and we also consider 2 factors, that is, one is distinct function and other is the value of the K. And the second one is the decision tree. This decision tree will be in the form of flowchart like structure, and random forest. The random forest here, it will be like tree like structures, and SVM. The SVM, it maps with input vector X into a high dimensional feature space. And coming to the order probit, here y star equals to x beta plus gamma, where y is the injury severity level and xb are the vectors, and the gamma is the error. So, and coming to the final one, the MNL, it captures the relationship between the injury severities and explanatory variables. So by using machine learning models, which treats the crash injury severity modeling, so these crashes are classified into different categories according to the severity levels. So initially we will train the label data set, and also we will test it in order to get the predictions of crash injury severity. So the ordered probit model will estimate the relationship between injury severity and explanatory variables or factors, and MNL will individually explain the each severity level change. And we have, as I said, we have taken 2 data sets which are trained and tested. So the accuracy will be calculated in this format, like accuracy equals to CP by N, where CP is the correct prediction of injury severity and N is the number of observations with injury severity in the data set. From here, my friend will continue.
Coming to the results, I'll just walk through you guys about how we compared our 6 models and how we got the results. So this is the structure of our program. So we wrote like for different methods, we wrote different in different methods, like data structure. We wrote in data structure in Python. Like this we wrote, and we got like this. So from here, as Bona mentioned, so we are collecting, we have taken 2 data sets. So like you can see here, so that is the data set we got here, and we are reading this data set, and we are executing this code, and after executing this, we'll get like accuracy and precision and F1 score, and like this. for different methods we executed like this only. So we can see here MNL and order probate and SVM and KNN, like this we already executed. And those things like what we did is, for example, I'll just take MNL. So after executing the MNL, so we got this result like accuracy and precision. So we are capturing this and keeping in this dot CSV, that is scores MNL dot CSV. So here we are capturing this and saving it here. So coming to the comparison, this is the main thing we are doing. So here we are reading all the things like as I mentioned, scores mnl.csv, like that we did, and we saved in different folders like this, and we are reading, and this is what we got. And if we execute this, so we'll get a result in a graphical format like this. And so like this. So we got two different set. This is for data set 1, which having around 7K records, and this for second data set around 3K. And so this is the accuracy for data set 1 for different models, and this is the data set 2 for data set 2 accuracy for different methods like this. By comparing two data sets, we can see here. So by comparing two data sets, we can conclude this MNL having high accuracy rather than other methods. And even for data set 2 also, we got 88.33% other than remaining methods. Order probit also we got like that only. So so we just segregated like this. And lowest will be the order probit will be the lowest, even we can observe. So for data set 1 it is 81%, and for data set 2 it is almost like 55%. So like this we got for different you can see for this is accuracy, and for data set 1 and data set 2 we segregated like this, and we did for all 6 methods. So finally conclude that, and so MNL will be the highest accuracy for both the data sets. So focusing on the comparison for the predictive performance for crash injury severity between various machine learning methods and statistical methods, based on the crash data collected at freeway diverge areas, the models were developed for predicting the injury severity associated with each crash. The predicting accuracy for each model on the training set and testing set was calculated and compared, as you can see. So finally MNL will be the highest accuracy, and order probit will be the lowest accuracy. Thank you.